Hello everyone and welcome back. Today I'm back from a break on this project, but I wanted to come here with a little lesson I put together to teach about an algorithm called binary search. So remember what an algorithm is from our previous video. If you haven't checked it out, check out one of those. I think it's maybe the first video I did in the coding series on Python. Remember, that's seen on my channel. You can go to the playlists and the coding playlists. So you can, I think it was maybe the second episode where we talked about an algorithm. But remember, an algorithm is just an organized way of solving a problem in a finite number of steps. And then, so this is a place where we're going to see where AI, or where this algorithm is used, and also how it significantly changed people's lives. Zoom out a little bit. So we're going to open up our tool in the Bing browser. This is, remember, our large language model we're using. It's kind of like you can kind of think of it as a gateway to ChatGPT 4, from my understanding. It's the large language model being run in the background. But yeah, I guess for our theory, we're going to ask, please describe the theory of binary search. Of the binary search. Also, kind of just a quick segue to remember. So, remember what an algorithm does. It solves a problem, right? It solves a problem. Algorithmic thinking is important to problem solving in our world. So, with those kind of two basic ideas, you can kind of think about binary search is searching through a list of objects in a way which you'll see is more quickly than just scanning through an entire list. Given that the list is sorted is a certain precondition that you have to think about. Okay, so we're just going to grab all of this. Copy. Paste that in there. Hopefully this turns out working. All right. Okay, sweet. Looks all right. Okay, so let's just look around this. So the binary search algorithm is a fundamental technique used for efficiently searching for a specific element in a sorted array. Remember, it has to be sorted. That's the precondition. So let's delve into the details. Algorithm overview. So binary search follows the divide and conquer approach. It repeatedly divides the search interval in half, narrowing down the search space. So the key idea is to exploit the fact that the array is sorted, which allows us to reduce the time complexity significantly. So given a sorted array, we start by defining the search interval, initially the entire array, calculate the middle index, let's call it mid, within the search interval. If the key matches the middle element, the search terminates successfully. If the key is smaller than the middle element, we focus on the left half of the search interval. And if the key is larger than the middle element, we focus on the right half. So we repeat this process until either the key is found or the search interval is exhausted. So consider this array. Let's search for 23. So calculate the mid. So the mid up above, it says you calculate the middle index by counting all the elements divided by 2. But they get the middle index, in this case 16. So 23 is greater than 16. So we only look in the right half. And so now we look in 23, 38, and we keep on proceeding on with this process, and we see that the time complexity is logarithmic, right? We're dividing our search space by half each time, and each step reduces the search space by half, leading to efficient searching. This is just big O notation. If you're not familiar with that, that's all right. And this is just kind of a quantifiable way of describing uh, how how much time an algorithm would take to execute. But logarithmic time is pretty good, especially considering we could have a linear algorithm that just scans through until we find it, which would be linear and less efficient. So this is a sample implementation with a while loop. Looks like this might be in C++. And so um, here we have calculating our midpoint. We're accessing an array, and we're setting equal to x, returning m. If the array at m is less than x, we say left equals m plus 1. Otherwise, we say right equals mid minus 1. And then we return minus 1. If we never find that middle index, right? So if we never find this returns the index of the element, right? So, and then it even tells us, remember, binary search is a powerful tool for efficiently locating elements in sorted data structures. So for more details, you can explore resources here. Sweet. So that's a little bit about the theory behind binary search. And then I wanted to ask, can you give some specific examples for where binary search algorithm is used in the world, touching many people's lives? Okay. Oh, this is giving us quite a few examples. Okay, let me copy this. Change this to Markdown. And here's the response. So certainly binary search algorithm is widely used in various domains due to its efficiency and versatility. Let's explore some of the ways, examples where binary search plays a crucial role. So searching in sorted arrays, that's kind of the most naive way, but maybe when you search for a person in the phone's address book, finding closest matches, looks like machine learning and hyperparameter tuning, computer graphics, so ray tracing, texture mapping, dictionary lookups. So this is kind of a really applicable approach, but when you look for a word in a dictionary, which is sorted alphabetically, you can use binary search to shorten your process when you're looking for that alphabetical word. That's a great example. Notice that's kind of a biological system too. You think about searching anything in your horizon, you can kind of be looking and half in your search window. If you think about it, also kind of like how people use like clock-based directions is another way that you could kind of think about a binary search. like you're scanning along. It's kind of sorted based on time. Like when someone says, look at, 3 o'clock, and you're looking at 3 o'clock, but you're not seeing. That might not be a great example. That might be more of a linear search. Anyway, the square root approximation. So binary search can determine whether a number is a square of another number. For example, it can verify if a given number has an integer square root. That is kind of neat. Sweet. So now I just wanted to really quick go into a coding exercise in Python, actually. So remember, the binary search is kind of iterative or recursive. So I wanted to prompt, can you program a binary search algorithm in Python, and both recursive in Python with different implementations, and explore the trade-offs of each from a programming standpoint. There. Go ahead and implement that. So I'm going to add these prompts. It's going to be in the GitHub page. If anyone wants to go ahead and look at the GitHub project thus far. I'm going to try to be better at organizing that. I have missed out on some files. I apologize about that one. So I'm just going to add these in really quick. This looks like I have a typo. Make that mark down. And then the theory question. Okay, here we go. So this is kind of the first last thing, and if you have stayed to the end, I will quickly show a bonus question or bonus topic about binary search. It's related to interviews. So I have an electrical engineering background. I've gotten my toes a little bit wet in the semiconductor industry, and in the 2 companies that I've had experience in, both an internship and a full-time role, I was asked about binary search in the interviews. So I'll talk a little bit about that. Okay. So we're just going to copy all of this, I guess. Some of it is code. But let's just look really quick. So this is kind of a quick idea about the implementations. So remember, this is iterative and recursive. You can have 2 different ways. So the powerful technique for efficiently finding an element in a sorted list, like we kind of already talked about. But this is recursive. And so recursive overhead, remember that you're calling a new function every time and putting on the stack. So this consumes memory. So very large arrays, this could lead to a Stack Overflow. But it's concise and elegant code, demonstrates the divide and conquer approach. So you're returning a recursive call to the function, kind of neat. Um, and then there's the iterative approach. So iterative using a while loop, and this was what was shown in the C implementation. So it's no additional stack frames, uses constant space, can be easily converted into an iterative loop. I don't really know what they mean by that, but it's a little less intuitive because there's the absence of explicit recursion. I guess that makes sense. So conceptual clarity, the recursive version emphasizes divide and conquer. Remember how the array is split by looking at the middle and then comparing the element at the middle with what we're searching for, and then either changing your search window is a way that I like to think about it. It's like, okay, well, the element is less than this object, so we're going to look at the left, all the way from the left to this element, or otherwise we're going to increase our search window. So remember the teaching consideration of memory usage. There's a memory overhead of recursion called stack first iterative approach. Discuss the trade-off between elegance, recursion, and efficiency iteration. Right. So there are edge cases. So you have to handle the case where the target is not in the array. Otherwise, you will be stuck in essentially. Or if at least in the recursive case, because you will never return. Well, you need to return -1 or some element if you don't find the value. Otherwise, you'll get to the end and nothing will return, and your program might not handle that. And then real world applications, right? So that's huge. Connect binary search to practical scenarios, phone contacts, databases, search engines. It impacts performance in large scale systems. Remember, think about algorithm at scale, right? We're solving the problem of searching through sorted data in logarithmic time versus linear. So both implementations have their merits. That's what we see, and choosing on the right one depends on the context and specific requirements. So that is one thing that we really have to think about. It's like, okay, so you have a binary search. Where are you going to use binary search and why? Right? And like, what are the implications? But yeah, that's binary search. I hope this was helpful for you. If you know, maybe if you've learned about binary search before, if you never learned about it. I wanted to quickly bonus, just give two things I was asked in an interview about binary search. So in one company, I was asked to actually write binary search on a whiteboard. And also, I was given kind of more creative question to, like, what can you adjust in if you know your data is more centralized than maybe your left and right array. So let's say your array had like 0, 0, 0, and then 1, 1, 1, 1, and then maybe 2, 2, 2. But we knew things were not existing at 0, 0, 0. Well, let's say, so you think about it like this: 8, 9, 10, and we knew that, just for say some odd reason, we knew that from beforehand that the values were actually in this search window. What could you adjust? And it would be your left and right pointers to the beginning and the end, which you could update if you knew beforehand by some external knowledge that your element was actually in here. And that this is in the context of test engineering, where you are looking for trim code. trim code, which allows you to trim a value of an electronic circuit to a certain specification. So that's just a special idea, but sometimes we can have that, external knowledge that would help us to do that. So this was one kind of bonus question, and then the other one was, tell me what this piece of code does. But it was a C-level bitwise binary search, and that's a little bit more difficult. Bitwise meaning you're looking at a little bit different operators, but if someone might ask you, what does this piece of code do? C code do, and it was a binary search, and I'm not even gonna lie, I think I got this one completely wrong, and I got this one partially right. So those are just some ideas for bonus questions. But this is binary search. I hope that was helpful. I'm not going to run any of these, but feel free to try them out on your own machine. And yeah, if anyone has any feedback, feel free to leave it in the comments. We're running a little over time, but it's binary search, and I'll probably be working on a few more videos in the coming days. And yeah, hope y'all are well. Have a great rest of your night. Goodbye.